In this video I'm going to cover making through dovetail joints using a pantorouter. Based on the smallest dovetail bit I've got, I'm going to design a dovetail joint that has a geometry that I can still get away with, and then design templates including this pins template and the tails template, and then I'll show you how to get it all lined up so that the joints fit, and then we'll cut the joints. I'm going to start by working out the geometry for my dovetail joints. I want to make these as small as I can. So I'm using the smallest dovetail joint bit that I've got, and the width across the top of that one is 3/8 of an inch, which is about 9.5 millimeters. So I'm going to make the space between the tails, these would be the tails attached to the board, I'm going to make that 10 millimeters, so that gives me a little bit of slack. Now for cutting out the pins, that's basically this end grain here, I need to cut out this part here. I need to make a cutout for the tails, so the tails are going to fit in here, and my router bit has to fit in here. Now this bit is a 1/4 inch, but it actually measures closer to 7 millimeters. So I'm going to make this space in here 8 millimeters, so that I still have a little bit of room to move with the router bit. So together I'm going to have a 10 millimeter and an 8 millimeter for a 18 millimeter dovetail spacing. Let's start by constructing the shape for the pins template. The dovetail bit that we're going to use can cut the maximum depth of about 8 millimeters this way, which means I'm never going to have stock thicker than 8 millimeters, which means I also only need to guide for cutting the pins by about 8 millimeters deep. So basically this is going to cut like that, and I can't use boards thicker than 8 millimeters. Now that actually doubles when we get to the template, because the pantograph always doubles everything. So this is another 1/2 inch guide bearing, so we know that this needs to be able to move down by about 16 millimeters where it's still fully guided, so it needs to come down just this far. Now let's give that a little bit of extra. And since we're going to use a 7 millimeter wide cutter to cut this space here, at the narrowest point this thing still needs to be able to move back and forth by 2 millimeters, because again everything doubles. So let's just draw the outline of that and move it over by a couple of millimeters-ish here. So we need to have space for that. And let's draw some lines. I've got this bevel gauge set to 14 degrees, which is the angle of my dovetail bit. So that's going to be the angle that I need for the guides here. And let's draw a line here. 2 lines, and that's basically how this thing's going to go. Now the cool thing is we have this intersection point here, and because I don't want to do extra measurements, I'm just going to reference everything to that. So I'm going to draw a horizontal line where these points are, and now I'm going to measure 36 millimeter spacing, because that's our 18 millimeters times 2, so 36, 72. So now that I've got these tick marks here, I know that both of these lines intersect here, so I can just do everything down to those lines. Now my bearing only needs to come down about this far, but just to give me a little bit of safety margin, let's see, the bearing can come down as far as this before it hits both sides. So I really only need to cut these to about that depth. So let's draw another line on here. Okay, so basically these are the parts I need to cut away. Now I've only done this roughly on paper. So what I'm going to do next is I'm going to draw this on the wood itself, so I don't have to transfer the marks onto the wood. And I'm going to draw that a lot more carefully. Okay, so here's my template that I'm going to cut out. And I'm going to cut out these triangles here for the ball bearing to follow that. And I'm going to do that on the bandsaw. So I finished my tails template, and remember this is the one that the bearing travels in like this, which is essentially used to produce these cuts with a straight bit. Now for the pins, I don't need to make an angle cut at all because the angle is already in the dovetail here, and it just has to travel straight up and down. So what I need to do is to make a template which has got slots on it that my bearing can travel just straight up and down, and I want these slots to be just wider than my bearing. And I've cut these, I'm going to cut these on the table saw, and I've marked my interval of 36 millimeters on here, and I'm just going to put that in the sled and line that up with each of these and make the first cut for each of the slots for my bearing. I'm now making a second series of cuts lined up with a second tick mark. So between those two, I'll have my slots for the guide bearing. So here's my template for the pins, and here's my template for the tails. And the guide bearing fits with just a little bit of play in here. And let's just do a quick check to make sure the spacing and everything is alright. So these look like they fit all nicely. If one of these fingers was out of line, it wouldn't fit on one of them, so it doesn't look like I made any great mistakes. Now I need to swap out my guide bearing on the pantorouter to the 1/2 inch one that I've designed my templates to use. So now I've got it all set up for cutting my dovetails. That's the tail part of my dovetails. I've got the small dovetail bit in here, and I've got my tails template here, which is just the straight slots. Setting that up was relatively straightforward because all I had to make sure is if the bearing bottoms out, that my bit is just below the level of the table, so it's just a straight cut through all the pieces. So I'm going to go ahead and make those cuts. So I set up my pins template, and I cut myself a test joint, and you can see it was very, very loose. But this actually really helps me because I just need to measure the amount of gap that I've got there, and I know I need to displace that joint by that much, and that joint will fit perfectly. So to displace that joint, all I need to do is to move this template up by twice as much, because remember, everything gets doubled with the pantograph. So if I've got a millimeter gap, that just means this template here needs to move up by 2 millimeters, and we should have a perfectly fitting joint. I need to make sure is when I cut my pins is that I cut exactly where my dovetails are. So basically this is the dovetail, and I want my pin cutout, the cutout between the pins, to be centered exactly on that dovetail. So I've lined that up, and that is, the bearing is right in the middle of one of these. So basically each of these things here is going to hopefully line up with where the pin is, each cutout, so that my edges of the box here are going to line up. So here's my pins that I just cut and my tails that I cut previously, and it looks like the bottom edge here lines up, so I got that right. So let's put that together. It's a little bit tight. So, well, let's see. I have a tiny little bit of a gap right here on this one, so it's not perfect. But considering I cut these on the bandsaw, it's not bad. I haven't pushed it all the way together yet because I wanted these flush just to show. So let's push this all the way in. And there we go. So if I was actually making a box instead of just demonstrating the technique, I would have maybe not made these extend quite as far. Either that, or I would have extended them further and just sand them flush. So now that I've got my templates made, all I have to do is just to put it in the same position to recreate that joint. So the one critical measurement that I worked out is that this distance from this edge down to here is 55 millimeters. And basically, to get that same fit again, I just have to make sure that template is mounted at exactly the same height. The height of the other template doesn't really matter that much because I'm just cutting straight through. Now the other thing I found that it was really awkward to adjust the height of this part here. So I added some slots to my frame and made it so that I can put these bolts that I normally use for the templates up here. I can move these down here, which makes it a lot easier to move that template because I don't have to fiddle with the clamp. So dovetail joints is just one of the many things that this machine can do. I originally designed it mostly for mortise and tenon joints, but really any joint that you can cut with a router, this machine can do with the right template. If you want a machine like that, unfortunately it's not commercially available. It would probably cost way too much to manufacture. But you can build it. I have a set of very detailed plans for sale, so build one because it's cool.